Denver. It's been a few years in Orlando and currently work mostly in JavaScript, HTML, CSS front end, and then PHP on the back end with Node and Mongo, all that stuff. Anyone knows what I'm talking about and they want to jam about it, hit me up later. But today we're talking about Git, and good thing my head's not in the way. Now, I want to ask, raise your hand if you've heard of Git. So pretty much the whole room, raise your hand if you haven't heard of Git. That's okay, this is why we're here. So everyone's heard of it. Who has used it? Okay, a lot of people. So a lot of this is going to be a rehash for most everyone, but it's going to be the basics, get up to speed, and kind of talk about together what it is to use Git in a group and kind of go through it. You most likely have this set up. The two things we'll be having on our computers is just your basic terminal. If you have an OS X computer, Mac, Macintosh, whatever, iTerm, terminal app, or the command line. If anyone's using Windows, they have the GNU tools in there. That's cool. And your favorite editor, because we're not going to pigeonhole ourselves into anywhere. Now, Git. Git is what people call a version control system, and if any of you have worked on a project tossing files over email and Dropbox, you know how it is to get something and kind of have to merge things by hand. So Git is something that lets you do things much more smoothly. There's like an internal database that keeps all think of snapshots of your work from commit to commit. Now, the Git architecture has three basic things. Four if you're getting detailed, but you're thinking about repos, you're thinking about commits, and you're thinking about branches. Now, if any of you have used another version control system like CVS, Git is different. What's known about Git that people love is that it's distributed. It lets you have a point of truth all over the world. You could have your projects hosted at GitHub, you can have your projects hosted on your computer, open up to the world. You can even work distributed, say everyone's working on the same computer, but you have a distributed point of truth with Git. Now, does anyone have any horror stories of using the distributed model of Git? Raise your hands. Any horror stories? So no one. It's pretty cool. I love it. So that's what's cool about Git. Now, first thing that I really want to do is just show a couple pictures, overview of the Git object model. Now, since most of you have used Git, I'm not sure if everyone's looked at the object model. I found a great set of slides that, to me, kind of elucidated how things are connected, how things work together. So, the Git object model, you start with a blob. Now, you can think of blob. Here they said it's content under version control file. That's basically what it is. It has a few different things inside the blob. It has like a header, it has a set of hashes inside of it, and it can also be compressed. So it's kind of like just a regular file. Now, you can have trees of blobs. Tree is basically like a record that says, okay, we're connected to these trees, and in myself as a tree, we have these blobs. And it kind of mirrors the same directory structure of the files in your repo. So it's, straightforward there. Tree and a blob, it's basically your directories and your files, just set up in Git format. And now we have our commits. Now, just like it says it's a tree of blobs and a set of changes, if you look inside of a commit file, it's going to have just records of your trees, your blob, where it's connected. So commits connect to each other, and there are things called tags, but we're not going to talk about that today. And just like it says, a graph of commits belongs to a branch. You can have orphan branches and all that, but that's also advanced too. All of these are files, they're just files. But what Git does is organize it using the paradigm of thinking in trees and hashing your files just to keep things compressed and ordered with its own sort of labeling and reference system. Now that's different from lots of different version control systems. Lots of different version control systems, they just keep track of differences made to files. That makes it difficult to have branches and kind of, it's an expensive thing to have branches. You can't do lots of complex things with branches and other version control systems like you can with Git. So now there is something called the head, and you'll see, which you've all probably seen, the head, which is you have your index, which has a record to the head, and your head basically points to a branch and says, this is where we're starting. This is what we're talking about. We're currently speaking of these files. And you can move the head around, kind of like a little magnet. Place it from branch to branch to branch. So, focusing on commits and branches, we're going to move to other things. Now, we talk about object database before. The three things we mentioned were, the blob, the tree, and the commit. Now there is something as a tag. The tag is kind of like a reference to a point in your repo. There's a couple different kinds of tags, but you can think of it just as a reference when you say, I'm going to tag this commit with this label. And you can easily say, okay, I'm going to tag it with version 1. Version 1 of all my code is set to this commit. Version 2 is set to this commit. It's a quick reference, kind of like now, we're going to go kind of back to basics, talking about our branching model. Now, we're going to kind of fly through this, just talking about branching and merging, but it's a visual example, a visual model that we keep in our heads of what branches are and how commits relate to that. So when we think of our repo in Git, we think of our head and we think of master. And when we're working in a classical kind of team environment, we have our set of changes in the master branch. Now the master branch you can think of as kind of the mainstream. It is the Mississippi River of our code. And all our branches are kind of going to be tributaries off of that. We can merge them back at different times, but our master is traditionally the branch we're going to use to release our code. Not our working code, our distribution code. So when you create a new branch, it's automatically going to have a master branch, which is going to be the main thing there. Now, who has questions about branches right now? Just to start off, get a feel of anyone thinking, okay, branches are interesting. You said the word branch a lot. Well, what does it actually mean? Does anyone have any questions around that? Everyone's pretty solid there? Okay, cool. Oh.
Like you're releasing a new version, right? It's branched out if you want to take something that has updates on the feature set.
Yes.
That'd be an example of a branch or other examples that would be more appropriate.
Mm-hmm. Say the business side is asking for a feature, and they've got a lot of ideas about the feature, and they've given you a Photoshop file and saying, okay, implement this feature, put together these pieces. You could create a new branch off your master branch, and we're going to see what that kind of looks like right now.
But that's not like a full fork.
No, it's not a full fork. No,
it's still within the main project.
Absolutely, yeah. We've got our experiment, right? This is going to be the branch we're going to do our feature in, and it's going to get a new kind of branch object, it's going to be a new commit in our Git object model. And it's going to point to the last place where you branched off, the last commit that you branched off on the master. Now, so we'll look at it. This is this C2 right here. This is where our experiment starts. We just made a commit. We took our files, we added new features to it. Maybe we added a new function, we put new CSS, we put some new HTML in there. And we made a commit. So this commit that we made branches off the master, but you notice the C2 in our object model, it's going to refer to C1. It's going to say like this tree is connected to that tree, and it's going to have like a hash inside of it. If you want to do a deep dive into that, you're going to see some really cool things. And I'll actually give you a link to this slide, because this is the best slide deck I've seen on Git so far. Now, you keep on making commits. Now, notice that now we're not referencing master anymore. We're referencing from the last commit that we made last time. Keep going. We're going to check out master, but now notice where the head is. The head before was on our experiment branch, and once again, the head is where we're pointing to where we are. It's our point of truth in time. Where are we? The head is going to say that. Now, say we want to move back to master. All our code is going to be at the state of C1, whatever that is. You know, maybe the feature we were working on, it's in a prototype phase there. Maybe there's nothing there. It's the initial commit of a product, and all it has is a README that says, do something. Now, we can make commits from that master just like we did our branch, but none of the code that we did in our experiment branch is going to appear in this next commit. Now, here they're showing tags, and they're showing a great example saying at this point on our master, we're going to tag it v1.1, so we can access that tag somewhere down the line. Now, here we are. We're thinking, okay, we've worked on this experimental branch a lot. We've taken it to the point where the business guys, they love it. They've got all the features, it's got all the styles. Okay, let's bring it into master. We're going to push it up to staging environment. It's going to be real. So we're going to do something called a merge. Now we're going to talk about it more. We're going to experiment with it. If you haven't done before, it's going to be new. If you have done before, just going to be so happy to see it done again. But notice when we do the merge, that C5, right, the last part of the experiment that was unique, now that's going to merge our code, C4 and C5. Those two parts of our branches, they're going to come together, and Git's going to use, you know, semi-intelligent, you know, heuristic-based merging strategies. Really smart people, Linus Torvalds and the kernel community there have come together and made sure that, boom, we've got some sweet tools to make sure that merge is good. Now, from that, we've kind of seen how branches work, we've kind of seen how commits work, we've kind of seen that commits always refer to the last commit, just so that there's a point of truth. And each time we make a commit, it's not going to be the differences of the files. It's going to actually be snapshots of the files in whole. So say you have, you know, big files in your repo, and those are changed, and you're actually tracking the change of those files. You're going to be making lots of copies for those files. But memory is cheap. You know, shrug. Memory is very cheap right now.